Hey kids, today we're going to talk about how to find the area of a regular polygon. Now you got to remember that there's a few fancy words that make up the word regular, and those words are equilateral, which means that all the sides are going to be the same, and the other one is equiangular, which means that all of the angles are going to be the same. So we're talking about regular polygons in which all the sides and all the angles are going to be the same, and how to find the area of those. But I don't want to focus just on all of this idea of regular. What I want to do is I want to focus on how to find the area of this. So what we want to do is we want to actually add in a few things. One, I'm going to eye up where the center of this is. It's roughly about right there. And two, I want to throw in these lines to make these triangles. Now, the idea of regular polygons just isn't all sides the same, all angles are the same. It also incorporates the idea that this pentagon is made up of congruent isosceles triangles. So I know that all of these sides are the same. I know that all of these are the same because it's from the center to each vertex. So basically what I have here is I have this isosceles triangle that is congruent to all of these other isosceles triangles. So what I want to do, if I want to find the area, what I can do is I can find area of one triangle and then multiply by the number of triangles. So remember, all I need for a triangle is a base and a height that are perpendicular to each other. So here would be the height, this would be the base, and all I would need to do is figure out the area of this one triangle and then multiply by how many triangles actually make up the shape. So here is number 6 from the worksheet, and there's actually two ways in which we can go about and solve this problem. The first way is going to be taking a look at this isosceles triangle, remembering that there are 5 of these same types of triangles in here. So the height that I just covered up was 13, and what I want to do is I want to figure out what this part of the triangle is right here, and I get that by Pythagorean theorem. Pythagorean theorem will give us a 9.5 when we round to get that side. Now, if I want to find the area of this triangle up here, remembering that all of these triangles are the same, this equation is 1/2. Okay, so 1/2 base times height. So the height we just said was 13, and the base of the triangle, remember, is not 9.5, but it's 9.5 times 2, which will give me 19. And if I multiply this out, 1/2 times 19 times 13, I'm going to get 123.5 units squared. But remember, this is for one triangle. And what I want to do is I want to find the area of the entire pentagon, which is not just one triangle, but it is finding all 5 of these triangles. So if I go through and I take 123.5 times those 5 triangles, I will get 617.5 units squared. So that is one way of looking at it, by finding the one isosceles triangle. Another way of looking at it is just taking a look at this right triangle. I still get this side as 9.5 by the Pythagorean theorem, but now this triangle, still the equation 1/2 base times height, but the base of this triangle is the 9.5 the height is going to be the 13, and when I multiply those out, I get 61.75 units squared. Now I got to remember how many of these triangles are in the pentagon. And I could draw them all in, but there are going to be 10 of those triangles, which will still give me 617.5 units squared for the entire shape, because now I am figuring out all 10 of these triangles. Next up, dealing with the regular polygons is going to be a regular hexagon. So remember, hexagon has 6 sides, but there's some important things to know about this hexagon when we draw in these triangles. So drawing in these triangles, we're going to add that right there, draw in this, and then one more. So there we go. We got all the triangles in. We can see that they intersect at the center. But remember, these aren't just any old isosceles triangle. I have all of these sides are going to be the same. I just drew in these, which these are going to be the same. And taking a look at all of these angles in the middle, I know that all of these add up to 360 degrees, think circles. And now, if this is 60 degrees, and these two sides are going to be the same, these two sides are going to be the same right here, all of the angles in this triangle add up to 180, so these have to be also 60 degrees. So if I'm going through, I see that this regular hexagon is not just made up of any old isosceles triangle, it is made up of 6 congruent equilateral triangles. So here it is, last example of the day from the worksheet. And we're going to take a look at how to find the area of this regular hexagon. Now remember what we just talked about. A hexagon is made up of equilateral triangles. So if this side right here is 12, that means that this is also 12, but it is only regular hexagons. Is that true? Don't try and do that for any other regular polygon besides a regular hexagon. So now we can take a look at this right triangle. First of all, if this is 12, I know that this side here is 6, and then Pythagorean theorem is going to give me 10.39 in order to get this side. Okay, so that's a 3. There we go. So now what I can do is I can find the area of this triangle. This triangle is 1/2 base times height. The height is 10.39. The base is going to be 6. I multiply all of these together, and that is going to give me the area of one triangle, which is 31.17. Now remember, this is just one triangle, and this is made up of 12 of these type of triangles. So I want to multiply by the 12 triangles. So if I do that, it gives me an area of 374.04 units squared. So one way of doing this is by using Pythagorean theorem to find the sides that are perpendicular in this right triangle and multiply by the 12 triangles. Another way of doing this problem is to take a look at this right triangle here as a special right triangle, where this angle up here is 30 and this is going to be 60. So if I take a look at that special right triangle, we got to remember the sides of the special right triangle. Remember from our notes that the short leg is going to be A, the hypotenuse is going to be 2 times A, and the long leg is going to be A times rad 3. Well, dealing with these numbers, I know that I have the hypotenuse is 12, the short leg is 6, so this side is going to be 6 rad 3. So now what I have, the area of this triangle is 1/2 base times height, where the base is going to be 6 and the height is going to be 6 rad 3. Multiplying this out, it gives me 18 rad 3, remembering that this is one triangle. So now I'm going to take this and multiply by the 12 triangles, which is 216 rad 3 units squared. And 216 times rad 3 is going to give me the same answer. So there you have it. We have one way by Pythagorean theorem, and then we had another way by special right triangles. Either way will work out, just as long as you can figure out one of them and go with that.